Yes, on Friday. And I'm also recording this class, so I'd really like to get started. Ferris, you need to be seated there, please. Okay, so yesterday, when we talked about the inverse of a 2 by 2 matrix, we came across, Ferris, you need to be back in your seat, please. I gave you this equation, and we came across this term here, okay? And I told you that that term is the determinant of this matrix here. Okay, it's the determinant of this matrix here. So today what we're going to do is we're going to learn how to find determinants of different matrices, 2 by 2, 3 by 3, and so on. And we are also going to see how determinants come in handy, okay? How they make life easy sometimes. Sometimes, not always, but sometimes they make it really easy. So to begin with, please take note of this, okay? A determinant is merely a number. Could be either positive or it could be negative. Okay, it could be either positive or it could be negative. Now for a 2 by 2 matrix, the way the determinant is calculated is by going down the red diagonal and timesing the two numbers on that diagonal minus going down the blue diagonal and timesing the numbers on the blue diagonal. That's why I think of determinants as red minus blue. And I kind of use this because we'll use the same kind of technique for a 3 by 3. Okay. Anything beyond a 3 by 3, we will just use the N box to do it. Okay. The book does explain. So those people are going to be serious about math next year and perhaps in college as well. You might want to really read the work that the book does as to how to find determinants of matrices that are bigger, okay, more than 3 by 3. It's a pretty involved maths. Well, it's not math so much as arithmetic. It's a lot of arithmetic, okay. And while I'm on the subject of arithmetic, I would like to say that you really want to do all the homework and all the problems thoroughly because, seriously speaking, the content in this chapter is nothing more than arithmetic. Okay, it's all about multiplying, dividing, subtracting, and adding stuff. And if you are, can I finish? And if you are challenged that way, then I'm telling you, your quiz and your test, you will be challenged. Because there will be addition, subtraction, multiplication coming out of you know where. Okay? Question? Yeah. So everybody get the red minus blue stuff? Sorry? Well, what can I say? Not much I can do. You can make it red and green. Okay? So make sure you get this answer for the example that I have. Now 2 by 2 is pretty trivial, okay? There's not much arithmetic going on there. 2 multiplications and a subtraction. It's easy. Okay, everybody get a 1 there? Is everybody all right there? Yeah? Everybody got that down? Okay, moving on to 3 by 3. So 3 by 3 gets a little involved, but again, it's all about multiplying, adding, and subtracting. Okay, so get that example down, and then I'll kind of quickly go over that with you. What was that, Ryan? Don't forget the minus sign there. Okay? And then you go on the blue diagonals. and times the numbers. So you get that, times that, get that, times that, get that. And then eventually you get only one number. Remember, that number can be either positive or negative. Okay, it can be either positive or negative. Now let me just talk briefly about notation, okay? Remember what I told you, the determinant of a matrix A is often written like that. Now sometimes this confuses people because then they might get a negative answer and then say, oh, that's an absolute value, so it shouldn't be negative. That's not the case, okay? So keep this straight, okay? Keep this in your head straight, okay? If you're finding the determinant of a matrix, it can be negative. It can be negative. That's why some books like to write it like this, because there is no ambiguity there. DETA, and we will see this in the N box in a few minutes. Okay? That's what your N box uses as well. DET. All right? All right, is everybody okay? All right? So everybody get red minus blue? All right, so I want you to try your hand at it then. Try your hand with this, and then I'll show you how to do it on an N box. Okay, special kind of matrices, okay, triangular matrices. Yeah, they're special for this very simple reason. I'll tell you that in a minute. Okay, so first of all, notice that this is a triangular matrix. It forms a triangle like that. Everything that's off the diagonal on one side is 0. Okay, we saw that when we are doing row echelon form. Okay, when we are doing row echelon form. Okay, so triangular matrix that's in that form, its determinant is simply the product of the things on the diagonal. Oops, that's not what I wanted. I wanted blue. So it's just 5 times negative 1 times 1, which is negative 5. Doesn't matter how big the triangular matrix is, okay? It could be 1,000,000 by 1,000,000. All you need to do is multiply the things that are on the diagonal. Okay? All right?
Multiply everything?
Okay, is everybody all right there? Yes. Now, if it was like this, Anna, if it was like this, 3, 0, 0, negative 7, 0, negative 7, 1, 0, 5, 2, 7, then you could multiply this, except it would be a negative answer.